During the interview, you must show that you're smart, resourceful, and resilient, and methodological. Show the method even if you don't know. Problem, test cases, design, verify code, then test. Into my past internship at Northrop Grumman, I've never experienced what it was like to read or write Python or C#, and those were the two program languages of which we used during the internship. In order to pick up those two languages, as well as the process for the unit testing, I spent numerous days watching YouTube videos as well as reading numerous documents in order to pick up those two skills. Unit testing involves testing the individual components of the software, and the main purpose is to check that all the individual parts of the code are working as we intended. The unit testing ensures that all of the code meets the quality standards before it was sent out into the the work environment, and in order to ensure a reliable product. A CVE, short for Common Vulnerabilities and Exposures, is just one of the few things that I've never heard of before I started that internship. And a CVE is a list of publicly disclosed computer security flaws. The scan will reveal the issue so that the program can adjust the code to adhere to the security standards. This is prominent in coding because the system on the internet is consistently scanned and attacked from outside sources. So a low score is what is desired because it revealed that there was a low chance that the attacker could gain access to the code, and the high score meant that there were no special conditions that needed to be met without gaining access to the code. In my previous internship with Northrop Grumman, we incorporated Agile values in order to achieve our daily goals. Through Agile, we worked together as a 6-person team in order to design, develop, complete, and test a network simulator application for the government. Failure. That's a very good question. VirtualBox failed when we were trying to implement when we were trying to decide which software to implement the network on, and VirtualBox is a GUI and command line tool that makes it possible to deploy servers, desktops, and embedded operating systems such as virtual machines. A single VirtualBox host can deploy as many guest virtual machines as the host hardware can handle. But the reason the VirtualBox failed was because it used a lot of resources. We also tried an application called QEMU. QEMU was a machine emulator that ran off of operating systems and programs for one machine on a different machine, for one machine on a different one. Mostly, it was not used as an emulator, but as a virtualizer in collaboration with the KVM kernel components. In that case, it utilizes the virtualization technology of the hardware to virtualize guests. And the reason that QEMU was optimal because it was very vulnerable to hackers, and that wasn't what we were trying to implement in a government network. So then we tried Docker. Docker was a containerized way to write applications and take what VirtualBox does and make it faster and more compact. And it's faster than QEMU as well, and is also safer. And with Docker, you can make a ton of virtual containers with low storage and RAM. And at the end, we stuck with and used Docker to develop the network. Culture. What is the work culture like, and how do you implement the lean principles and the things that you do? What type of projects do you foresee interns working on in the future? What is leaving you hesitant for hiring me for this position? What is a day in your life of work like for you? What is the type of projects do you foresee interns working on in the future? Star. S. Briefly describe a time when you experienced that situation. Identify the most important points to give the best understanding of that situation. Don't spend too much time. T. Explain the not important actions that you took to meet the goal or address the situation to achieve success. Focus most on your story in this area to show that you're a great fit for this role. A. Explain your role in the goal or task you needed to accomplish. Don't spend too much time on this section. Tell the outcome or result of your actions, what you have learned, and how you've been able to apply what you learned going forward. Focus on the impressive results and quantify if possible. What are Boeing's core values? Our values. Start with engineering excellence. Be accountable from beginning to end. Apply lean principles. Eliminate traveled work. Reward predictability and stability everywhere in our business. How we act. Lead on safety, quality, integrity, and sustainability. Safety, quality, integrity, and transparency must be on the forefront as we design, build, and service our products. We live these values by holding ourselves to the highest standards of conduct in how we do our work and how we treat one another. Boeing's core values are typically summed up as being integrity, quality, safety, diversity and inclusion, trust and respect, corporate citizenship, stakeholder success. Start with engineering excellence, making world-class quality the foundation upon with everything that is built, and focusing on safety and integrity. Be accountable from beginning to end, ensuring that responsibilities are understood and managed from suppliers to sales and marketing. Apply lean principles, that is delivering the maximum value with minimal waste. Eliminate travel work, get things right the first time around. Reward predictability and sustainable stability everywhere in our business. Collaborate with humility, inclusion, and transparency. Here is that guiding principle of people working together and surfacing again. The selection tree algorithm sorts an array by repeatedly finding the minimum element, considering an ascending order from the unsorted part and putting it at the beginning. Merge sort. Given two sorted arrays, the task is to merge them together in a sorted manner. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping and adjusting elements if they are in the wrong order. A hash function takes in data like a string or file content and outputs a hash, a fixed size or string or number. Big O notation is the language we use for talking about how long an algorithm takes to run. It is what we compare the efficiency of different approaches to a problem, and it's like a math, except it is awesome, not boring kind of math where you get to wave your hands through the details and just focus on what's basically happening. Here's what a logarithm is asking. What power must we raise this base to in order to get this answer? A triangular series is a series of numbers where each number could be the row of the equilateral triangle. So 1, 2, 3, 4, 5 is a triangular series because you can stack the numbers like this. Memory or RAM is faster but has less space, while storage or disk is slower but has more space. A monolith type. A memory controller does the actual reading and writing to and from RAM, and it has a direct connection of each shelf of RAM. A series of characters, letters, punctuations is called a string. We can call each of these integers a pointer since it points to another spot in memory. Just make an array and program to resize itself when it runs out of space. It's called a dynamic array. And it's built on top of normal array. Linked lists have worst case time appends, which is better than the worst case. Big O of 1 time appends is what linked lists have. This data structure is called a hash table or hash map. In our hash table, the counts are the values and the words are the keys. The process we use to translate a key into an array index is called a hashing function. Arrays have big O of 1 time hookups, but you need enough uninterrupted space in RAM to store a whole array. And the array items need to be the same size of the array value that's allocated. But in your array stores pointers to any actual array items, you can get around both of these weaknesses. You can store each array item wherever there is space in the RAM. And the surface and the array items can be different sizes. The trade-off is that now your array is slower because it's not cache friendly. Another problem with arrays is you have to specify their sizes ahead of time. There are two ways to get around this: dynamic arrays and linked lists. Linked lists have a faster appends and prepends than dynamic arrays. But dynamic arrays have faster hookups. Fast hookups are really useful, especially if you can look up things not just by indices, but by arbitrary keys. That's what hash tables are for. The only problem with hash tables is that they deal with hash collisions, which means that some hookups could be a little bit slow. An array organizes items sequentially, one after another in memory. Each position in an array has index starting at 0, and a dynamic array is an array with a big improvement, automatic resizing. A hash table organizes data so you can quickly look up the values for a given key. A stack stores item in a list, last in, first out. A graph organizes items in an interconnected network. Each item is a node or vertex. Nodes are connected by edges. A binary search algorithm finds an item in a sorted list, big O log of n time. A brute force search would walk through the whole list, taking, let's say, the sorted list to find a number in a binary search. We start with the middle number. Is it bigger or smaller than our target number? Since this is sorted, this tells us that the target will be a left half. What we've officially divided the problem in half, we can rule out the whole half of the list that we know that doesn't contain the target number. Repeat the same approach, starting in the middle, a hash size new problem, and start again. And then rule out the whole set. Breadth first search is a method for exploring a tree or graph. In a breadth first search, you first explore all of the nodes one step away, then all of the nodes two steps away. Breadth first search is like knowing a stone is in the center of a pond. The nodes you explore ripple out from the starting point. Here's how a breadth first search would traverse this tree, starting with the root. Depth first search is a method for exploring a tree or graph. In a depth first search, you can go as deep as possible down one path before backing up and trying a different one. Depth first search is like walking through a corn maze. You explore one path, hit a dead end, and go back and try a different one. Here's how depth first search would traverse this tree, starting with the root. A brute force algorithm finds a solution by trying all the possible answers and picking the best one. Say that you are a cashier and give someone 67 cents using a few coins as possible. How would you do it? You could try running through all the potential coin combinations and pick the one that adds the 67 cents using the fewest coins. That's a brute force algorithm, since you're trying all possible ways to make a change. Here are a few other brute force algorithms. Trying to fit as many overlapping meetings as possible in a conference rooms, run through all the possible schedules, and to pick up the schedule that fits the most meetings in the room. A greedy algorithm builds up a solution by choosing the option that looks the best at every step. Say you're a cashier and give someone 67 cents. How would you do this? Whenever picking, let's go to the examples. Trying to fit as many overlapping meetings in a conference room as possible. At each step, schedule the meeting that ends earliest. Memoization ensures that the function doesn't run out of the same inputs, for the same inputs more than once by keeping a record of the results for the given inputs. Brute force solutions are usually very slow since they involve testing a huge number of possible answers. Short circuit evaluation is a strategy most programming languages, including Python, use to avoid unnecessary work. A garbage collector automatically frees up memory that isn't taking up space anymore. Array slicing involves taking a subset from an array and allocating a new array with those elements. A hash function takes data like a string or file contents and outputs a hash, a fixed size, string, or number. A mutable object can be changed after it's created, and an immutable object can't. A problem has an overlapping subproblems if finding a solution involves solving the same subproblem multiple times. As an example, let's look at the Fibonacci sequence. The sequence here is the number of sums of the previous. If we wanted to compute the n, we would have to use this simple recursive algorithm.